The following question reads that a teacher sets up the apparatus shown to demonstrate a double slit in the fringe pattern on the screen. So there's a double slit, these are the double slits over here, and they have a separation of Q. And this is a single slit, a source slide over here. R is the distance between the screen and the double slits. So which change to the apparatus will increase the fringe spacing? Here on the diagram, I've constructed two fringes. This is the first bright spot that would appear on the screen because the rays from the two slits, they're going to meet at this point in phase. And then a short distance away, there's going to be another bright spot. There's going to be a dark spot in the middle, then another bright spot. And the two rays from the two slits are going to meet in phase again, and another bright spot is going to be formed. So fringes would form on the screen all the way across, a very bright fringe in the middle, and then fringes on the sides because the waves keep on meeting in phase. Wherever they're meeting out of phase, that's where you're going to get a dark spot. Now the formula that determines fringe spacing is given over here, where Q is the slit spacing and Y over R. Y is the fringe spacing divided by R is the distance between the screen and the double slits, and it's equal to n lambda. So this is the formula that we are dealing with. And now the question is, which change to the apparatus will increase the fringe spacing? So the fringe spacing was Y. So I've rearranged the terms in this formula, and I've made Y the subject of the equation, and now you're going to get that Y is directly proportional to R, the distance. So the fringe spacing would increase if you keep on increasing distance. You can, and it's pretty obvious that if you put the screen further away, the distance between the fringes, it's going to increase. And so Y is directly proportional to R, inversely proportional to Q, which means the smaller the Q is, the further away the fringes are going to appear. And it's directly proportional to the wavelength, lambda, as well. N is a constant because every time the waves interfere, they're going to have a phase difference of n lambda. Now, the options which we have, what change in the apparatus will increase the fringe spacing? So decreasing the distance P. P is not going to really matter. Decreasing the distance Q, that is, if we decrease the distance, the fringe spacing Y would increase, so that appears to be correct. But let's also have a look at the other options as well. Decreasing the distance R, if you decrease distance R, directly proportional decrease R. If you decrease R, the fringe spacing would decrease as well. So bringing the screen closer, the fringes would be closer together. So that is not going to work. And decreasing the wavelength of the light, so it's directly proportional to lambda. So if you increase lambda, then fringe spacing would increase. So decreasing wavelength is also not an option. So the correct option for this question is going to be option B.